Okay, welcome everybody to IndEx Insight, recent hydrogen developments. So we wanted to put this one on because our last presentation was very in-depth for some and perhaps not in-depth enough for others. This one is to take a step back to give a little more history of what has happened in the past, the present, and the future with what's going on with the hydrogen industry and why the push. And is it happening right now or is it in the future? So my name is Michael Merrington from IndEx, and appreciate everybody attending and appreciate your time. Now, is hydrogen the future? Well, the reality is significant investments have already been made by governments in the US, Australia, China, EU, so European Union, 26 or more countries, Japan. There's also new players to the game, new facilities, but also existing owner operators, the likes of Total and others that are looking to transition or are transitioning to hydrogen. And we have to consider the human factors. We spoke about this before in our past webinars. Human-induced faults are 99.9% of faults. And height, well, that has to do with human factors. The media is pushing it. The new players are pushing it. But also, people are pushing for reduced carbon outputs. So we're talking about environmental. So what's the demand? Well, the reality is humans. As we look on the left, we have share prices of hydrogen fuel cell companies. They've gone up significantly and had a sharp downturn, obviously during COVID, but the stock price is going up is being driven by humans, our emotional responses, yeah? Now, demand for hydrogen, this is direct production of hydrogen or usage via other methods. So in refining, it's been going up, the dark blue. 2018, this was last taken. So there's more projects coming online. We are seeing a gradual curve up, but if we look at an exponential curve, you know, everything looks slow when you go year by year or every 3 years, but eventually an exponential curve will take off and you'll wonder what happened. Well, what is happening in the industry? Investments, a drive, and the hype. Hydrogen could become a $130 billion US player by 250. Could it also cut emissions? Well, in the EU, that's the main drive, is to cut emissions. Now, the drive is a lot of people for a clean fuel source. When people say that solar panels are a clean fuel source, they're not considering, you know, supply chain management. To make a solar panel takes the glass takes a lot of coal in a furnace. Now, hydrogen, as we can see here, these are predictions of hydrogen's share of the final energy demand. So right now we're probably at between 10 and 13%, and they see it going up. But this is just existing feedstock. Then there's transportation fuel. They see by 2050, it could be 27% of all fuels. Fuel for industry, fuel for residential, power generation. But obviously, this is a prediction. Now, when we look at all the different types of industries, well, like we said, fuel and transportation, power generation, fuel for residential and commercial, feedstock for industrial and long distance transport, yeah? Ships, bulk carriers, passenger ferries would be for, probably fall under here a little bit, or another industry. Then also for research and development. And as we advance, we'll get into industrial processes, Yeah, transportation such as by ship, not just for shipping containers, but by transportation of people, which you'll see in later slides is already happening. So in America, there's already 50 hydrogen fueling stations within California, and their plan is for 200 by 2023. It's already in Australia, Canada, Japan, Europe. Now, where can we get hydrogen from? Well, one industry is making a big push for it. Now, the US Office of Nuclear Energy, well, they've been pointing out how nuclear can provide hydrogen as part of a closed loop system. You could use nuclear to create energy, to create hydrogen, to create power and energy, to feed a desalination plant, yeah, water from salt water. You could then use that water for your people and also water for the nuclear power plant. So once again, hydrogen generation, you can feed vehicles, have fuels, upgrading to oil, ammonia, metal industries, mining, lots of other end uses, power generation, heating, transportation, all the massive ship carriers, yeah, bulk carriers that ply our oceans. So from nuclear, there's many different ways that we can get hydrogen. A medium and high temperature steam reformation, medium high temperature thermochemical, and also electrolysis. So people are looking at nuclear as a potential option for producing hydrogen because there are many existing nuclear power plants in countries such as France, Germany, America, yeah, existing already there. It's actually quite an easy add-on for them. It's just using the heat, yeah. So nuclear, even the international IEEHA, international, sorry, I forget the name at this moment, but nuclear economics could favor small modular designs and produce hydrogen from it. No need for big massive projects that could perhaps go over budget or over time. So the EU announced just in March that there will be a clean hydrogen alliance for launch this summer. They've also invested, I believe, 130 billion over the last few years. Now, there's a few existing hydrogen stations, but they're planned stations. They're kicking into high gear. So the European Union released a roadmap. Now, the interesting thing is that they estimate that the final demand for hydrogen energy will be 24%. They also say that it could be an yearly revenue of 820 billion euros. Also, they talk about reduction in emissions and 5.4 million jobs across hydrogen, the equipment, the supplier industries. So that's for all the sub-industries, not just a hydrogen refinery, let's say. Now, they give estimates how things can be business as usual with very little investment of how hydrogen could come onto the market in which field, such as industry energy, new industry feedstock, heating and powering of buildings, transportation, and power generation. The EU is very ambitious when it comes to hydrogen. And during COVID, they are pushing more and more. So what do we see when we compare, let's say, hydrogen versus battery technology? Well, they find that for efficiency, passenger ships, bulk carriers are extremely more efficient with the use of hydrogen. Now, those vessels are already being produced. We'll show later. So obviously long haul, mining, international long distance road travel, distribution with a high payload is very good, but when you're dealing with low payloads, let's say a small ship, a small truck, it really doesn't make sense to go to hydrogen at this point. Once again, then they start getting into taxis and things like that, which is probably less of interest to the people that are watching. But heavy trucks, trains, planes, ships, vessels, that seems to be the push for hydrogen. So the big, high amounts, long distances. Now, the hydrogen economy, this is just a better visual representation of what's going on is, well, we already have hydrogen in all our processes in the hydrocarbon industry. LNG, oil, we can't, water, H2O, hydrogen, oxygen. We can get all these things from there. And then from the renewables industry, wastewater, also nuclear. And then what can it be used for? We've already gone through that, but visual representation. Now, when we dive into it specifically for, let's say, hydrogen generation, just for generation of it, the EU estimates that by 2050, there will be 967,000 jobs just for green hydrogen, so renewable resourced hydrogen, so not from the fossil fuels. So that's just the number that they said before, about 5.4 million. That's just for the renewables sourced. Now in Australia, they've already started doing this. There's a pilot plant in Victoria, Australia, basically Melbourne, Victoria, and they're starting to put it into their network. You can mix hydrogen with ammonia with your natural gas lines safely. So they're using natural gas networks to supply to vessels, to send to overseas for export, to desalination plants, to residential and industrial applications. And they're deriving it from existing oil and gas, coal, and also renewables. So just on May the 4th, the Australian government invested another $300 million to kickstart hydrogen. So in Australia, the Hydrogen Energy Supply Chain Project, a pilot project, is already under construction and actually has had further expansion. They've also completed their first liquefied storage tank onto a vessel. And within Australia, they've already defined where they can get hydrogen from their natural gas reserves, coal reserves, coal seam gas, wind, solar, and hydroelectricity. Specifically, Tasmania is a good one for that. So Australia is flush with hydrocarbons, sunlight, and wind. So this project is already on the go right there in Victoria. Well, as part of that, they've already built the very first hydrogen carrier. So we've seen LNG carriers. Well, similar, you have a hydrogen carrier. And actually just announced the other day, 25%, I believe, of LNG carriers do not have an owner. They're stacked up. Buyers are having apprehension, but the push to hydrogen is intensifying. COVID is obviously having impacts on these. So once again, just in April, ABB, very large, obviously, electrical company, engineering. You know, they produce many things. Well, they teamed up with Ballard Power Systems of Burnaby, British Columbia, Canada, to produce, well, megawatt fuel cells. And their plan is for bulk carriers, yeah, to be used. Now, the International Maritime Organization, the United Nations agency that regulates shipping, wants to reduce their carbon output by 50% by 2050 from 2008 levels. Hydrogen can definitely get them there quicker than LNG. Bulk fuel, bulk diesel, bunker fuel is has a lot of carbon. So the push is there and it's happening. Now, as we stated, well, in Norway, they already have all the designs planned out. And actually, there are existing ships that are, instead of going to an LNG conversion, are now going to a hydrogen conversion. In America, a company named Tote Maritime is already building the very first hydrogen-powered ferry in America. They're building it in Seattle, and it's going to go to the San Francisco area. And the world's first international supply chain was done by Japan, Brunei, and where they safely moved hydrogen from one country to another, had offloading facilities and storage, and then international distribution networks nationally. So it's already been done. So what has happened in the hydrogen in industry? Well, this explosion just happened at a place called AB Silicones. And what happened is 4 people died, and they found that it was unsafe working conditions. CSB and OSHA, basically their OH&S, HSE federal agency, stated that people were designed it unsafe, didn't classify it, equipment wasn't maintained, people were working unsafe, inspections weren't happening. The company said, we were working safe, this was an accident. So what is the probable cause? Human-induced faults. People always believe they are working safe, or that they did a risk analysis and that everything will always be okay. It's human nature. So ignorance is the probable cause, but ignorance is not an acceptable defense when a company or yourselves go to court. Just because you don't know, you say you know, but if an explosion happens when you're in court, it's not going to help you. So, another one just recently, April the 7th, 2020. Explosion in North Carolina at a hydrogen fuel plant. Brand new facility. 60 homes damaged, luckily nobody killed. Still under investigation. Company called 1H2. So people jumping on the hype train, it's fine. Hydrogen can be a safe gas when you include the correct people in the industry, hazardous area experts. Another one just happened back in 2019. Norway, at a fueling station. What was found? Well, a valve leaked hydrogen, which caught fire when it came in contact with the air. No, the hydrogen mixed with air, yeah, fire triangle. The oxygen, the fuel, and the ignition source. Yeah, remember, ignition sources can also be static electricity. hydrogen will go off with any bit of static electricity. Its minimum ignition energy is the lowest or second lowest of all the flammable gases. This one went off because the valve was hot and leaking. Well, what else has happened? Well, in 2010, in a refinery in Washington State, in USA, I believe 7 people were killed when a high temperature hydrogen attack happened to the heat exchanger. So hydrogen has a well-known history of being dangerous. Just remember, just because you don't know of these events does not mean they have not happened. If a tree falls in the woods and you do not see it, it didn't fall. So there are other examples, case studies, highlighting hydrogen explosions. Hey, this is Fukushima. What caused the Fukushima explosion? A buildup of hydrogen. Yeah, obviously there was events before that, but a buildup of hydrogen within the roof, within the building, was then ignited. Also, ventilation plays a big part, specifically in enclosed spaces, buildings, ships. So if we're converting vessels over to hydrogen fuel source, or they are hydrogen bulk carriers, a lot of enclosed spaces. Again, lessons learned. 2007, another one in Ohio. They found that hydrogen explosion occurred during routine delivery of hydrogen when the hydrogen relief device failed, which allowed the contents of the hydrogen tank to escape and be ignited by an unknown source. Well, there's 13 potential different sources of ignition. Static electricity is an easily overlooked one, which you can avoid with the correct use of clothing. Clothing produces enough static electricity to light things up, especially hydrogen, but also maybe hot surfaces. So they still don't know what ignited it, but there have been many incidences like this, okay? We want to give awareness of these. Well, even in Australia, the offshore regulator, what happened? Lead acid batteries exploded. They figured that electrolyte leaked. But the problem in the industry is that these valve regulated batteries are described as maintenance free, and they're less likely to produce hydrogen. Now the problem is that when people see maintenance free, well, human factors again, oh, we don't have to do anything. That is incorrect. That is unsafe. So the manufacturers using the word maintenance free, in my view, cause these issues, these human factor issues. If they would say reduced maintenance, but be aware of produced hydrogen, that would be much safer. Now, the lessons learned, key lessons that NFPA calls for is dedicated battery rooms should consider potential explosive gases, hydrogen, released under both normal operation, and here's the key one, and fault conditions. Most people do not consider fault conditions. Nothing will go wrong. As someone with many years of experience, and all of these articles just found easily in the last 30 minutes, I could have found that is incorrect. They happen constantly. Faults happen constantly. So you should consider use of explosive, protective, so hazardous area equipment. Hierarchy of control. Remember, PP's lowest: administration, engineering, and then you have substitution and isolation. The higher up you are on the pyramid, the safer, more efficient, least costly in the long run for your company, for your people. So, what about a safe, quality, productive solution? Well, standardization allows knowledge to be spread to us all in a format that should and shall, in my own experience, be applied consistently worldwide. There are national deviations, but if we work from the same set of standards, well, then there'll be less issues. Give you an example. Air Canada in the 1980s killed, I believe, about 150 people. Canada was transitioning from the imperial system to the metric system. They fueled up incorrectly. They thought they had to fill up with gallons still instead of liters. Their plane did not have enough fuel. It crashed and killed everybody because it did not have enough fuel to make it to its final destination. Yeah. Human-induced faults. This happens all the time. And this will happen when international companies are going into America and America is selling internationally. These measurement conversions, errors, they happen all the time. Now, what's going on in America? Well, NEC 505 is classes and zones. They are transitioning. As for time frame, they are transitioning to the same standards as the rest of us for hazardous areas, 60079 for electrical equipment in hazardous locations, hazardous areas. NEC 500, classes and divs, that's a different story. Now, when we call for NFPA 70, the National Electrical Code, it refers to NEC 505 when it comes to working in hazardous areas, hazardous locations. Requires equipment to be construction and installation must be ensured to perform safely under conditions of proper use and maintenance. Also, the inspection authorities and users, so installers, inspectors, owner-operators, EPCs, shall exercise more than ordinary care with regard to the installation, maintenance of equipment, electrical equipment in hazardous areas, locations, classified locations, all depending on your terminology. Now, implementing that, classification of areas, engineering, design, selection, wiring, installation, inspection, shall be performed by a qualified person. So in America, they call for this, but what is a qualified person? That's still coming. Now, all these things are already called for under IEC when you look at competencies in -14 and 17. So installation, design, selection, erection, so installation, and for electrical installations, inspection and maintenance. Also, there is repair. So also classifications of hazardous areas. Can one engineer, who is a chemical engineer, do classification? Yes. Do they know anything about electrical bonding, earthing, grounding, functional earthing, instrument earthing, lightning earthing? Raises a lot of questions, doesn't it? I would say perhaps not. That's not their competency. That is not their qualifications. Perhaps you should include a chemical, process, mechanical, electrical, and instrument engineer, like they do for HazUp, HazID, for when defining their safety integrity level requirements, their SIF, their SIL, for their facilities. Does functional safety go before hazardous area considerations? If a gas detector detects gas, but was not selected to be hazardous location protected, an EX protection technique, so it can detect gas, could also ignite it. It doesn't sound like a good idea. Probably best to order, let's say, an EXT flame-proof gas detector, then figure out which SIL rating. That would seem to be the common sense approach. So, what's going on? Well, there's an international standard, which the comments will close on the 11th of May, which is removing competencies from 14, 17, and 19 of IEC 60079, equipment for hazardous areas, and will be approved at the end of 2020 or at the beginning of 2021. Now, the people involved with that are some interesting people in the field. There's somebody from SBM, another very famous person from the United States. There is also many inputs from Great Britain, France, Norway, Turkey, Australia, Italy, Germany, China. Everybody's involved. Also, my managing director. And also another very well-known person from Australia that has advanced these standards. So the standards already exist for the hydrogen industry, just not everybody has awareness of it. So what solutions do we have to perhaps training, competency, and helping people out? There is IECEx COPC, Certificate of Personal Competence. You can get this for yourself. It is one possible solution. Online database. Everybody can be found. Much higher level of quality management system. Okay. So hopefully that wasn't too in-depth for some people. We want to thank you for this webinar. It was more to show what is going on, what will happen, what has been happening, the faults that have been happening in the industry, and just this was more of an awareness session. So if you have any questions, we are open. Somebody asks, zone classifications for hydrogen dispenser are based on a HazLoc study. The interesting thing is that each facility is different. To apply something such as a recommended practice in certain countries as a copy and paste methodology, we've already seen explosions happen where people have followed that methodology. They thought they were being safe. I would not say one for one copy and paste from your one facility to another. Now for the HazLoc study, did the HazLoc study include people that were competent in hazardous locations? Did they have experience? Also, has that experience been measured? Yeah. People can say on their CV, on their resume, that they're experienced. Does that mean they're experienced? If you're the end user, the EPC, the operator, I would measure, test that competency. The problem is many in the industry will go, they have a certificate, they're good to go. Or they're an engineer. Let me point out, qualifications only mean like 15 to 30% of competency. Competency is skills, knowledge, and experience. When you get your engineering degree, that means you have some knowledge. There is no guarantee, there has been no measurement of your skills or experience because you gain that in the industry over the years. Okay. Who can obtain a certificate of personal IECEx COPC? Anybody can. There's 11 different units to choose from. What sort of experience is required? Well, if you have a safety background, you can do it. There's different units. Classification can be done by any engineer, even some technicians. if they can pass the examination, certainly. How many years of experience required? That can be defined in our brochure. If you wish to get your IECEx COPC, we can do training, and we can also help you do your certification. Qualifications required, depends on the person. If you're a mechanical background, show your mechanical engineering degree, electrical, chemical, anybody. Everybody that should be involved in a hazardous area classification, chemical, process, mechanical, electrical, instrument, meteorologist, safety, really, they should be trained and have their competency assessed. Is there any specific course study to make our self-experts in the hydrogen industry? We do customized training. So if you wish for that, yes. The hydrogen industry is quite new. The number of experts is growing, but it's still obviously small compared to the oil and gas industry. IECEx online examination. Certain units are available for online examination, depending on the IECEx certifying body. If you wish for these things, please send an email to me. How would H2 result in a cradle-to-cradle comparison between different methods of producing to other renewable and non-renewable fuels? Well, those studies have been done, but obviously we're not going to be able to go in depth in the period of time. There are studies. Now, the interesting thing with the studies is that many of them have different opinions. So the thing is, one would say that nuclear is the cheapest to produce hydrogen and the safest, while others would point to biomass. Biomass is burning trees, wood chips. Photovoltaic, well, those solar panels sometimes only last 5, 10, 20 years. How many trees do you have to wipe out to get enough power? Same with wind turbines. What about the birds? So a direct comparison has been done in a few studies. We didn't show it this time. If you send an email, I can give reference to some, but there's about 5 or 6 studies that I've seen, and they're all over the place. As for methods, well, hydrogen's already part of the long chain carbon molecule long chains in oil and gas. So to get hydrogen from LNG, from oil, sources of oil, depending on the type of oil, the type of condensates, it's much easier because we have the existing facilities. Nuclear is quite easy, but it's new. They're just coming up with it, or I should say, finally starting to invest more. So when comparing, I would say that the existing fossil fuels industry is the easiest source and probably the cheapest solution, because as we showed in Australia, they are already using their natural gas supply network to move it. So they're able to separate it, combine it, and then separate it again down the line. So it's already being done, but it's also still being researched. But we already know with natural gas, it's a hazardous area. So how difficult is it to comply with? Well, let's hope all of our equipment is 2C in the area where they are doing the combination and splitting of the hydrogen. What year do you believe coal may run out globally? No resource will ever run out. The earth is very deep. It depends on economics, prices, yeah. Coal, like I said, with solar, when we look at solar, it's not a clean process. There's a lot of chemicals and minerals, especially wind as well, that we have to mine for, which takes energy. Yeah, we could convert those trucks to hydrogen, but to do a furnace, well, we use coal to do iron. Yeah, all of our structures for our buildings and big facilities and ships, well, we use coal. So when people say we're going green, they've produced solar panels, or let's say a battery grid. Some places like America, cost matters most. So coal production is needed to run the coal power plant because there's only a coal power plant. And when it's cloudy and the wind isn't blowing, you need power. And in all actuality, in most countries, even in Germany, when they say that they've gone completely green, they say wind and solar have taken over. I believe they make up less than 13% of their actual power. The rest is biomass. Trees chopped up in Canada, America, and sent to Germany and burned. There are better solutions. Wastewater, nuclear, to produce hydrogen. There are true renewables. If you look at a thorium salt reactor, thorium is much safer than uranium. It only has a 50-year half-life. If you want to research anything on thorium, look up Kurt Thornston of NASA and the thorium liquid salt reactor. 50-year half-life. If you lose power, it separates. In a high temperature reactor, you have uranium. So if we look at Fukushima, what happened there? That's where the fuel is a solid and the coolant is a liquid. When it comes to thorium salt, liquid, the fuel is liquid and the coolant is a solid, nitrogen rods, I believe. So it's quite an open-ended question when you compare the different renewables and non-renewables. What does the word renewable mean? I think I've shown or spoke about how perhaps wind and solar is not renewable. Do those wind turbines last more than 20 years? Or do they break down? Have we seen pictures of photovoltaic solar cells broken in the deserts of California? I certainly have. We could go on for hours and hours upon that, but we don't have the time, and that would be for another discussion. If no one has any more questions, we will thank you everybody very much for attending. I hope you found this entertaining and enlightening, that what's going on, what has happened in just the last 3 months. There's been a lot of announcements of investments, building, and explosions. And why do these explosions happen? Lack of awareness or the human factors. That'll never happen to us. I've never seen that happen before. We know what we're doing. We are safe. We are not like the insert country name. We are not like the Chinese. We're not like the Americans. We're not like the Australians. Perhaps we should learn the lessons that others have already gone through. When you don't apply lessons learned, well, that's just ignorance. And when something blows up, ignorance is not going to save your business. It's going to drive your business under. Your workers will lose their jobs. I would say there's better things that we can do within our industry. And I'm very positive that we can. Okay, thank you very much. We really do appreciate that you guys took this 1 hour out of your day. And should you need any services, should you want to get any further training, consultation, customized in-house training for your business, please contact us. at info@ind-ex.ae. Thank you very much for your time. Have a good morning, good afternoon, and good evening.